Hello and welcome to CMG's first webinar in the 2018 series. Today's topic is efficient simulation, leveraging CMG's latest performance enhancement technologies. My name is Anjani Kumar, and I'm the Vice President of Engineering Solutions at Marketing at CMG. I'll be the moderator for today's session. I'm pleased to introduce Khoi Duong, Account Manager at CMG, who will be presenting today's webinar. Khoi, you've been with CMG for a little over 10 years, right?
That's right.
So the first 5 years, Khoi worked as a reservoir engineer and worked on simulation of advanced recovery processes, especially specializing in chemical EOR and optimization of field scale chemical EOR processes. Subsequently, Khoi moved into the sales role, and he is one of the account managers for the Canada region. Khoi holds a dual degree in a BSc in biochemistry and an engineering degree in oil and gas from University of Calgary. So at this time, I'd like to inform you that there will be a question and answer session at the end of the presentation. However, you may submit your questions at any time using the chat window on your screen. We will also post the recorded version of the presentation on our website within the next 24 hours. You can use your CMGL login using your username and a password to access the material. So over to you, Khoi.
Thank you, Anjani. Welcome, everyone. Once again, welcome to our very first webinar of 2018. Today, I will discuss the new performance enhancement technologies that can be found in our latest general release and how you can leverage these to improve the efficiency of your simulation workflow. So over the course of the last 40 years, CMG has always been the leaders in technologies and innovations. And we were able to do this by either pioneering new technologies or were the first to incorporate new technologies into our simulators. We were the first to incorporate adaptive implicit methods into our simulator. We were the first to use QNSS, which is an improved version of the multi-phase flashed solution that's applied to the matrix solver. We were one of the first to parallelize our simulators over multiple cores using a Parasol solver. And this has made us the fastest and still is the fastest commercial simulator out there. We are the only one to offer dynamic gridding, which is the ability to change your grid size as your simulation progresses. About 12 years ago, we introduced CMOS and CMOS AI, which was and still is the most comprehensive software to assist you with your sensitivity analysis, history matching, uncertainty analysis, and optimization workflow. A couple of years after that, we introduced the unconventional modeling workflow, which uses tartan gridding to properly model your hydraulic fracture. This works in conjunction with CMOS to provide an automated workflow to help you better understand your unconventional resources, as well as to optimize your fracture designs. A couple of years ago, we've automated our numerical tuning workflow, once again using CMOS. This allows us to use the CMOS optimization engine to help you to obtain the most optimal numerical parameters for your simulation run. The last three here are what we'll talk into detail today. The first one, we Autotune AI, which is a one-word, one-step numerical tuning to give you the best optimal numerical parameters. The second one is our new combinative solver. This solver improves the performance of our linear solver on problematic nonlinear problems. And finally, it's our MPI. And MPI allows us to parallelize our models across multiple CPUs as well as across multiple nodes. So because of our ongoing R&D investment, every year, including this year, we have provided performance enhancement technologies along the entire workflow. Because for this year, we've improved Builder, we've improved the load time and the interactions of the models with our users. For the simulators, as mentioned before, we improved the runtime by having new linear solver and parallelizing technologies, as well as the automatic tuning for faster runtime. Now, all these three work in conjunction to give you a multiplicative speed up in your runtime. And on the back end, with results, we improved the load time, as well as the file size, so that you can analyze these data much more efficiently. Okay. Now, not only that we improved the workflow, with the introduction of CMOS AI, we now can capture improvements from the beginning to the end of your project. Okay. CMOS AI incorporates machine learning and artificial intelligence, and provides you with additional performance and efficiency in all of your workflows. So let's take a look first at our pre-processing improvement. Right? The one trend that we start seeing a lot now is that models are getting bigger and more complex. While Builder works really great with typical models, with these big models, you require more memory, and we tend to see a slowdown in the loading time. Right? So with these large models and with new Builder, we improve the memory allocations as well as a gridding algorithm to significantly reduce the loading time. So on this chart here, you can see the loading time of our latest version, 2017, is much, much quicker than what you've seen from 2 years ago. Even from last year, we managed to improve in it by at least 10 to 15%. Now, with this improvement in loading time, we've also improved the 3D visualization performance of our model. So these large models now will rotate a lot smoother. You can access different sections much easier, and you can update the data and the parameters much quicker. Another software we've added to help with the pre-processing is CEdit. Now, those of you that have used CMOS in the past, you might recognize CEdit as an editor that you can find in CMOS. For this year, we've taken CEdit out as a standalone product. CEdit now will work with both CMOS as well as your standard text files, as well as CMG datasets. Okay, so a quick glance at CEdit, it might look like any other text editors out there, but we've added a few features that we think will significantly improve your work within CEdit. So first, we've changed our layout to include very simple, very easy to read icons. And with these icons, we introduced a one-click navigation. So by clicking on any one of these headings, CEdit will take you to the appropriate and corresponding section of the model. So for example, I want to see the numerical section. I click on numerical methods control. It will take you right to that section of your model. Another improvement we've added is the highlighting of the syntax. So when you open a CMG dataset in CEdit, it will highlight your keywords blue. Right? It will leave all the corresponding data or numerical data black, right? And any comments shown up as green. So with these, you can quickly look at your model and you can see what is what you can change and what you cannot change. Another very useful feature we've added is the ability to collapse or expand an array. So anyone that's used a text editor to edit a data set, you know that scrolling through this massive and large array is tedious and very frustrating. So we've added the ability to able to collapse and expand this array with this one little button here. So with an array collapse, you can quickly switch from one section of the model to another without having to scroll through thousands of lines of numbers or codes. So one last feature we've added are modification markers. Okay, these are the yellow bars that show up on the left-hand side of your text file, and it indicates an area where information has been added or revised since you last saved this model. So all these features combine to make it more efficient, much better organized, much more user-friendly, so that you are spending less time generating data set and spending more time doing the actual simulation itself. Now, speaking of simulation work, if you've done any simulation work, you must have heard of numerical tuning. Right? So while the CMG linear solver has been evolved to work very well, to be very efficient and very fast with the majority of the problems, occasionally we do run into models that are numerically complex that might need some numerical tuning. And we do numerical tuning on these models for three primary reasons. One is to increase the accuracy by maintaining a low material imbalance error. The second is to improve stability, so better conversions and lower solver failures. And finally, and perhaps the most important, the reason we numerical tune a model is to improve the speed up, to make it run faster. Now, anyone that's done numerical tuning in the past, you know that there is a negative correlation between the speed up or the speed of your run versus the other two parameters. Right? For example, we look at material balance error. We can see that the lower material balance error tend to have a longer runtime, and vice versa. The shortest runtime tend to have a higher material balance error. So when you do numerical tuning and try to pick the optimal solution, you will pick something with a compromise in between these two. And that solution is shown in red here and typically lies on the Pareto front on a plot like this. Historically, to hit a plot like this, you would have done it in two methods. One is manually, so manually changing your parameters, run it, get your results back, and change your parameters again, and repeat the process. A couple of years ago, we've automated this process by using CMOS. Okay, so we now can take advantage of the CMOS experimental designs, as well as the CMOS optimizing engine to get you the same results in much quicker time. So the CMOS workflows work extremely well and extremely robust. But for this year, we made it even better. And we made it better by the introduction of Autotune AI. Autotune AI is an artificial intelligence-based adaptive time-stepping control. Using only one keyword, Autotune AI will apply the optimal numerical settings that will be beneficial to your specific models and processes. Right? Using this one keyword, stars and gem will run anywhere from 2 to 12 times faster in our latest version. So how easy is it to use Autotune AI? I'll show you a quick demo on how we can add or activate Autotune AI in either stars or gem. So here's my launcher interface. I take my stars model, I drag it into CEdit. Okay, so within CEdit, as mentioned before, I can go to my navigation pane, and with one-click navigation, I can quickly access my numerical section. I type in Autotune, save my data set, and now when I drag and drop the star data set into stars, Autotune is active, and now our numerical parameters for this run will always be optimized as the run progresses. In gem, it's very similar. I take my gem data set and I open it in CEdit. Once again, under navigation, I go to my numerical methods section. So the keyword in gem is slightly different. The keyword in gem is ADTSC. It's a gem equivalent of Autotune keyword in stars. Save my file, close it out. Now, once I drag my gem data set into gem, Autotune or ADTSC in gem is now activated, and it's rerun with the optimal numerical parameters throughout the run. So how do these look like in actual results? So here at CMG, we conservatively estimate that you will see a 2 to 3 times speed up by using this feature in 2017. And now you can see here some of the testimonials from the numbers we get back from our clients that the speed up is very case specific. It depends on what you're doing, it depends on your model, it depends on your processes, and it depends on your regular default numerical settings. Right? But for gem, we see anywhere from a 3 times up to a 17 times speed up. In stars, similarly, we see anywhere from a 2 times up to a 16 times speed up. So all of these can be found on our website, and I encourage you to visit it, check out other testimonials, and leave feedbacks if you have any for us as far as what you think Autotune is and if it's helping you. Some further testimonials, Comet Ridge used ADTSC in the gem simulation and saw a 3 times speed up. On the star side, Oxy Oman used Autotune in their steam flood model, and they saw a 2-time increase in their speed up. So once again, visit our website, check out all the testimonials, leave us some feedback if you have any.
Thanks, Koi. At this time, I'd like to pose a question to the audience. The questions will appear on your screen pretty soon. And the question is, have you used Autotune or ADTSC on your models? And you can respond by clicking either yes or no on your screen. We'll wait for a few seconds here to be able to see the responses. And because it's a relatively new feature, we have launched it around end of December, and we announced it. A lot of our customers have started using it since then and have shared with us their test results and their benefits and speedups that they have obtained. As Koi mentioned, the speedups are subject to the models that you are seeing. So anywhere between 2x to 17x is what people are reporting. It also depends on how well your model is originally tuned. And some of these models were originally tuned using CMOS or either manually using experience. So Autotune did help, but the speedups were not that significant. But still, it's better than spending time manually tuning your complex simulation models. And since it's a one keyword solution, try it and give us feedback. We are continuously improving this feature as it was recently launched. So any feedback that you may have will be really, really appreciated and well received by our development group. So it looks like the polls are complete as expected. Since it's a new feature, not a lot of people have tried it. 85% of the respondents say no, they haven't tried it. 15% of the people attending today have tried it. So good that people have started to try it. We are really, really excited about this feature, and I hope that it will help improve your productivity and get the maximum benefit from your simulation efforts. So over to you, Koi.
Right. Thank you, Anjani. So once again, feel free to leave us some feedback on what you think of Autotune AI. So the next improvement I want to talk about is our combinative solver, and this can be found in all three of simulators, IMAX, GEM, and STARS. Right. So our linear solver has been evolved over the years to become very efficient and become the fastest simulation linear solver out there in the industry. However, once in a while, we do run into problematic data set that might cause an issue with the inner solver. So looking at the very simplified diagram on the right here, so on the outer edge, we have our time step control. Right, within that time step control, we have a number of Newton iterations, typically 10 to 15. And within those individual Newton iterations, we have our matrix solver iteration or linear solver iteration. So in these problematic data set or nonlinear data set, we see a bog down or a bottleneck within this matrix solver. Right, so if there's a bog down this matrix solver, it's harder to converge. And if that takes longer to converge, then it takes more Newton iterations to converge. And that negatively affects your time step control. So the new combinative solver improves the simulated performance by improving the efficiency of the linear solver. So we're improving the efficiency right at the core. So now your linear solver is much more efficient, which in turn it converges much quicker, which means your less new iterations is needed, and therefore you have a better time step control for your run. So how exactly does this work? So our current IOU solver, or Paracel solver, once again, works extremely well, very efficient for the majority of the issue. Works by taking the Jacobian matrix and put it through a series of iterations. Now, in those problematic data sets, right, we see a slowdown of this iteration, and the slowdown typically is because of our pressure matrix. Now, pressure is always a primary variable, so it's always being solved implicitly. So if pressure becomes an issue, this slows down this iteration loop. It takes longer to converge, and in turn takes more Newton iterations, and in turn negatively affect your time step control. So with the new combinative solver, we have a slightly altered workflow than before. So what we do is that we extract the pressure matrix out of the Jacobian matrix. We precondition this pressure matrix, and then we use this new CMG solver as part of the second iteration loop to solve the pressure matrix. Once this pressure matrix is solved or very close to be solved, it's reinserted back into the Jacobian matrix. And the Jacobian matrix, once again, undergoes the same IOU iteration loop. The only difference here is that with the pressure matrix almost solved, this iteration loop will converge much quicker, and in turn reduces the amount of new iterations that's needed, and in turn give you a better time step control. Overall, this gives you a very good speed up on your runtime. So how does this look with actual data? So our combinative solver works extremely well in dual continuum model, so tight oil, unconventional oil and gas, or in processes with a rapidly moving pressure front, such as water flood or SAGD or steam flood that has mobile water. All right, so looking at the first three cases on the left here, we see a modest increase of around 1.3 times in our speed up. For the water flood case, we saw a really great improvement, right, and reducing a runtime by less than half. So once again, water flood has a rapidly moving pressure front. So this is one example where combinative solver works extremely well to reduce your runtime. The ESXD case is very specific to this one case. And the reason we did not see any improvement on the run is because the original ESXD case was already running extremely well and extremely fast. So using combinative solver in this one particular case saw really no difference in your runtime. The SAGD case here with the flex well number 3 saw a significant reduction in runtime. And the reason for that is that this SAGD case has mobile water. Once again, a great candidate for using combinative solver. Our last model here, tight oil, saw a 1.5 time increase in speed up. And for that case, I'll go into a bit more detail. It's a real Bakken reservoir, very large model of 6.2 million active grid blocks, dual permeability, 37 different wells with multiple hydraulic fracturing stages on each of the well. So the original runtime for this case is 198 minutes. Using combinative solver, it now reduced your runtime to 135 minutes. So we saw a 1.5 time increase in your speed without having to use any additional software or additional hardware. So once again, this is a brand new feature. Please try it out and send us any feedback, any comments that you have. Our next improvement, once again, can be found in all 3 of our simulators, IMAX, GEM, and STARS. It's our new Paralyzation technology. So before I go into detail on that, let's take a look at a layout of a typical compute node. So at the very bottom, you have your compute node, which is your self-sustaining standalone unit that has its own power supply, its own input and output, its own operating system. Right? Now within that computer node, you have multiple CPUs or central processing units. These are your brains behind your actual computer. Each CPU has its own memory bank, and each CPU can communicate with each other. Right? Now within each CPU, we have cores. Cores are individual threads, and these cores can either act independently or in conjunction with other cores within the same CPU and within the same compute node. So in parallelization, in the simplest form, is dividing a large model into smaller submodels that can be solved simultaneously across multiple cores. So here we take a very large model, we break them into smaller submodels that can be solved on the individual cores. And you can see where the advantage lie. The advantage lie in 2 kind of things. One is that these smaller models are much more simple to solve, so they can be solved a lot quicker. And secondly, these submodels are solved concurrently and simultaneously, adding additional improvement in your runtime. So over the course of the years, right, CMG continued to evolve our parallelization technologies to take advantage of current as well as future hardware configurations. So there's 2 primary methods to parallelize our models over multiple cores or CPUs. One, for shared memory, we use OpenMP. Shared memory is anything that occurs within a CPU that's sharing a memory bank. And the second, which is brand new, is hybrid OpenMP, which is used for distributed memory, which is across multiple CPUs or multiple compute nodes. So let's take a look into detail onto the shared memory method. So OpenMP here improves your performance within a CPU or memory bank. So we look at this model, right? This model sits on one CPU within one compute node. So all these cores, while separated, are still share a memory bank. So by sharing a memory bank, OpenMP allows better communications, quick communication between these submodels. So these submodels can be run and recombined very efficiently to show very significant runtime. In distributed memory, we're not looking at only sharing memory banks. We're looking at sharing across multiple CPUs which have separate memory banks. And on top of that, we have multiple computer nodes which have their own memory and their own input and output. So in this case, what we see are memory barriers. So now the bottleneck is not the actual calculation or the simulation of the submodels. The bottleneck becomes the communication between these submodels across multiple CPUs, as well as multiple compute nodes. So we solve that by using a hybrid OpenMP MPI technique. Now this improves performance within a core using OpenMP, as well as between different CPUs and different nodes. So MPI allows for better communication between CPUs, which have different memory banks, as well as better communication between compute nodes, which are two separate computers connected via a network. So looking at some of the runtime comparison for MPI and OpenMP. So for the first two, we saw no difference in runtime. And the reason for that is because these are across the same CPU. So within the same memory bank. So when you share a memory bank, OpenMP and a hybrid model gives you no difference in runtime. When we start seeing a difference in runtime is when we're spreading it across multiple memory banks. Okay, and this can be seen in the 16 and 30 core example. So while these sit on the same nodes, they're using two different CPUs. So there's a requirement for communication between two different memory banks. So this is where the benefit of MPI or the hybrid OpenMP MPI models can be seen. In multiple nodes, in two or more nodes, there is really no reason to run only OpenMP, since you now have to communicate not only across multiple CPUs, but you are communicating across multiple nodes. So for those cases, we ran strictly on OpenMP and MPI. And with these, we saw really good speed up going up to 256 cores. And we'll continue testing, and we will present you with even higher core counts down the road. So some benefits of parallelization. Okay, so parallelization allows you to improve your time and your memory limits to run a certain size model. You now not limit to what one computer can do. You can spread it over multiple computers. With OpenMP and MPI hybrid model, we can simulate a lot faster on nodes with higher socket count. So these are the one with multiple CPUs. Our implementation does not sacrifice accuracy. So your data remains, or your results remain consistent, whether you run on one node or three different nodes. Right? One big benefit is that now you can combine multiple existing computers. So you have a bunch of 8 CPUs lying around, you combine them to make 32 or 64 and not having to buy brand new computers. Another reason parallelization is beneficial is that now we can spread this across the cloud, whether it's CMG cloud or take advantage of the Microsoft Azure or AWS. We now can spread our run over hundreds or thousands of cores, further improving your work and your efficiency. The next feature I want to discuss is Dyna Grid. So as mentioned, Dyna Grid is unique to CMG and is unique for frontal processes. What Dyna Grid does is that it dynamically changes your grid block size throughout your simulation run to ensure that you have speed up while maintaining consistent and accurate results. So this here is the very typical cross-section of a SEGD model. We have a steam chamber, and anyone that's run simulation, we know that we want very small grid blocks so that we can perfectly capture all the mechanisms and all the behaviors of our models. The downside of having small grid blocks is that you have a lot of grid blocks in your model, and a larger number of grid blocks ultimately leads to a very long runtime. So how do we solve this? We solve this by changing our model from this to something like this. Right, so Dyna Grid will allow you to amalgamate or combine small grid blocks into larger grid blocks, or vice versa, allow you to de-amalgamate or refine larger grid blocks into smaller grid blocks. So we know that in a simulation like this, a lot of grid blocks on the outer edge are not changing. They'll have the same temperature, the same pressure, the same property. So Dyna Grid will use that to combine them into larger grid blocks to reduce the number of grid blocks you need. Similarly, inside the steam chamber, after it's been developed, the inside the steam chamber can be fairly homogeneous. And since all these grid blocks are very similar in properties, we can combine them into larger grid blocks. What's important is that we kept the grid blocks at the interface where all the cool stuff happened. This is where we have to calculate our mass transfer, our heat transfer. In those areas, our grid blocks remain small so that we can perfectly and more accurately capture those mechanisms. So this here will give you an optimal combination of speed without sacrificing any accuracy. So how does Dyna Grid perform in actual field models? So in combustion, we see about a 5 to 7 time increase in speed up. In SAGD and VAPEX, we could see about a 2 to 3 times increase in speed up. In cyclic steam, once again, about a 7 times speed up by using Dyna Grid. Right, so here's a quote from one of our clients here in Calgary. So Nexen CNOC saw a reduction in runtime by 95% for their hybrid steam and in-situ combustion by using Dyna Grid. So a significant decrease in runtime by using this one feature without sacrificing any of your results. So the next thing I want to talk about is our post-processing improvement. So for this, we've improved it in 2 ways. First, we've reduced the file size with the new SR3 format. And with this reduction in file size, we now can improve the loading time and your interaction with the new models. So anyone have used our product in the past, we know that we used to have 2 separate software for post-processing. We used to have Graph for your 2D or graph plotting, and we have the 3D version for looking at the models in 3-dimensional. And both of these use our old format SR2. In 2017, we combined these into one software, so both 2D and 3D is now in one tool. And this is now used the new SR3 format. So this is much more intuitive, much more user-friendly, and much more efficient in analyzing your data. So speaking of the reduced file size, how much reduction do we actually see between the SR2 and SR3? So here's a chart of some of the examples that we've run, and you can see that the reduction is fairly significant. On a more modest case, we saw around a 50% reduction in size. However, in some cases, we saw up to a 90% reduction in time. So our SR3 file sometimes is only about 10% of what our SR2 was. Of course, with this reduction in file size, we see a corresponding reduction in load time. So for this chart here, we've normalized the load time of the SR2 to 1. And as you can see, the load time to SR3 in all cases have been reduced significantly, right? In some cases, down to about 1/6 of it was before. So once again, with this reduction, you spend less time loading, spend less time worrying about it loading up, and allow more time for you to do the actual analysis, to look at your data and see what you can learn out of it. So one last thing I do want to talk about is CMOS AI. Now, I can't talk a lot about CMOS AI due to time for this one, but we do have our own standalone CMOS AI webinar in March. So keep your eyes out for the invitation. I encourage you to attend that session, as you will learn a lot of new features that CMOS AI will have to help you with your workflow. But for CMOS AI will leverage artificial intelligence and machine learning, along with human expertise to identify the optimal solutions. So with AI and with machine learning, we now can create accurate, data-driven proxies that allow you for quick and interactive what-if analysis. On top of that, we improve the workflow to be much more intuitive and new to help you improve your decision-making abilities. So here's an example of some of the new CMOS AI feature. This here is our dashboard interface, or our proxy dashboard or proxy interface. So for this example, it's an unconventional model. So you can see some of the parameters that we're changing, including your fracture parameters, your half length, your porosity, your perm, your endpoints of your rel-perm curves. Okay. So on the plots, what we see are the blue lines are your historical, your field data. The black line is your base case. And you might not be able to see it here, but you can see a bit of a reddish tinge, and that red is actually your simulation run, your optimal case. So when I play this video, you can see that as you change some of these parameters, your predicted value or your predicted results change along with it in real time, interactively. So this gives you the ability to quickly predict new results by just changing some of these parameters, right? And this prediction comes from the proxy model. And this proxy model is constantly changing and constantly getting updated as new data is being found. So once you've picked a set of parameters you like, you can do 2 things. You can add it to the experiment, right, to continue updating your proxy model, or you can actually run it as standalone and compare the results you see to what the model has predicted. Okay, so new CMOS also included a bunch of new automated results that will help you quickly analyze your data. Right? One of the more useful one is a stack bar plot. And in this case, we plotted global history matching versus all the different runs that we've run. So with each global history matching error, we can see how much of that is made of our individual global or local objective function. Right? From there, you can quickly isolate and see where the real issue is and focus your simulation and your study on that particular section. Another thing we do have is our proxy analysis model. Here you can look at different models, different analysis, such as the Sobel and Morris analysis, and see how your proxy models behave or how they are in a certain way. You can look at different proxy settings, and you can even export your proxy model out to Excel for you to work with your own software or to do your own analysis. So in conclusions, R&D investments have provided us and allowed us to continually add performance enhancement technologies along the entire simulation workflow. We improve our pre-processing with Builder and CEdit, faster data set creation, much better interactions with the users. For the simulation itself, we have improved Autotune with the Autotune AI, faster runtime with one simple keyword. Our new cognitive solver improved runtime for problematic non-linear problems. Our hybrid OpenMP methodology allows you to parallelize your models across multiple cores, multiple nodes, and allows you access to hundreds and thousands of nodes that are out there in the cloud. So these three work in conjunction once again and give you a combined speed up of up to 12 times in some cases. On the post-processing end, we improve load time and usability with our new results. And finally, CMOS AI encompass the entire project, improve runtime, improve productivity, and improve your ability to make the correct and the right decision.
Thank you, Khoi. We will now take up questions. If you have any questions and have already not submitted it, you can do so now using the chat window on your screen. I see there are already several questions on the screen that I can start taking it one by one. And the first question is from Ram Tirtha, and the question is, can combinative solver be used with a black oil simulator that is IMAX? Yes, definitely. Combinative solver is available in all the three simulators, IMAX, GEM, and STAR, so you can definitely use it in with IMAX. The next question is from Young One, and the question is, can Autotune be used with the geomechanics or for geomechanics speed up? Definitely, Autotune is a simulator keyword, so any of the functionalities that come with a standard simulator, whether it's geomechanics, whether it's any other feature, it's all can be used together, as well as combinative and Autotune can be used together to get a combined or a compounded benefit from each of those two features. So I'll take the next question again. The next question is from Ram, and the question is, can 2017 results read old SR2 files? Yes, in the 2017 version, we actually allowed results to read both SR2 and SR3 version of the results. From 2018 version, results will only read the SR3 format, and CMG will be making the 2017 and prior version SR2 formats obsolete. The next question is from Arthur, and the question is, speed up is always good, but could you comment on the influence of Autotune and combinative solver on the results of the simulator? Should we expect the results to change at all? If yes, how much the results change generally? The one thing that I like to highlight is CMG doesn't like to compromise on results or accuracy for speed. All of these runs that Khoi showed to you in terms of speed ups, the results were absolutely identical to without using the Autotune or the combinative solver. So there is no compromise in the accuracy and results when you use any of these features in our simulators. The next question is from Husham, and the question is, do I need to use all pre-processing performance improvement on all the, it scrolled on me. I'll reread the question here, is do I need to use all pre-processing performance improvement for all types of models, or anyone is suitable for special cases? Again, as Khoi mentioned, these performance improvement tools are very, very case specific. It depends on how complex your reservoir grid is, how complex your geology or property distribution is, what kind of EOR or any other recovery process you're trying to model, how well the original model runs. And again, as some of the cases that people have reported, and it's on our website, so do check it out. There's a wide variety of processes and wide variety of complex to simple reservoir models that people are using and seeing the benefit. I must caution that there are a certain number of cases which do not see improvement from Autotune. The reason being is that the base model itself runs pretty fast. The other is that the process itself is not suited for the Autotune algorithm to give you a speed up. But fortunately, those kind of cases are relatively small. I will say less than 5%. So do give it a try on your model. And if you see speed ups, that is really, really great. If it's not giving you the desired speed ups, then do get back to us, and we will appreciate your feedback and work with you on improving this feature so that you can get the maximum benefit out of these features. So again, Autotune, Combinative, all of these features or performance enhancement technologies can be used in combination to get the compounded benefit from your simulation runs. Okay, the next question is from Neha Bansal, and the question is, any plans to extend Autotune to IMAX? Actually, we are actively working on implementing Autotune into IMAX. There's a prototype already available. If you are interested, we can have it shipped to you to give it a try. It will be available in the 2018 general release that is expected to come out sometime in summer this year. So yes, Autotune will be available in IMAX very soon. The next question is from Husham again, and the question is, are all of these new modifications available in 2016 or 2017 version? All of these features that Khoi talked about is available in 2017 version of our simulators, except a few actually. Dyna Grid has been available in our simulators for over 10 years now, or maybe 15. And over the years, we have improved its capabilities quite a bit. So give it a try and see how it performs on your models. The rest of the features like Autotune, Combinative, and MPI are 2017 release features. I think I have time to take on one more questions. There are already several questions here, so do not feel left out. We will individually approach each one of you with an answer to your questions. And so the last question again, and I think I already took that one, is can Autotune and Combinative be used together? And the answer is definitely yes. And you can expect a compounded benefit from each of these features. So there's few more questions that we will not be able to take it for the sake of time, but we will definitely approach each one of you individually with a response in the next 24 hours. So I hope you found the latest performance enhancement technologies from CMG exciting. We are really excited to bring it to you, so I hope you will derive the maximum benefit from some of these simulation software capabilities. As well as if you haven't tried it, do give it a try and provide us feedback. We really appreciate your feedback. Check out the customer testimonials and customer results on our website. We showed you the link quite a few slides back. We will also post today's presentation on our website within the next 24 hours, so you can use your CMGL username and a password to access the material. In addition, if you have any other questions that wasn't answered, or if you would like to know more about our product offerings or any of the features that was discussed today, do not hesitate to email us at sales@cmgl.ca. We also have several training classes that we offer on a variety of subjects. If you want to attend any of these courses and refresh your skill sets on some of these modeling capabilities and use of our simulators, then do check it out on our website at cmgl.ca/training, and the registration is online. It's fairly straightforward. Again, thank you all for joining us for the webinar today on efficient simulation, leveraging CMG's latest performance enhancement technologies. And we do hope to hear on your experience and feedback on these technologies. Thank you again.